Somewhere out in the solar system, there's a place that seems to defy logic itself, as if reason and reality just broke down. According to every known law of physics, this place shouldn't even exist, not in any universe we understand. And yet, there it is, very real right before our eyes. It's a place that truly feels like hell, hundreds of volcanoes erupting nonstop, spewing molten lava into the air, all while the surrounding emptiness of space freezes everything around it. Hey everyone, welcome back. This bizarre and fascinating place is called Io, the fifth moon of Jupiter. Today we're diving deep into the story of this one-of-a-kind celestial body. Thanks for tuning into our channel. Let's get started. Galileo, Voyager, and the discovery of volcanoes. The very first person to ever spot Io was none other than the legendary Galileo Galilei. In 1610, he built his own telescope, aimed it at the night sky, and discovered 4 tiny, faint points of light orbiting Jupiter. Those mysterious dots turned out to be Jupiter's moons. And one of them was Io. Today, we know that this massive planet has more than 95 moons orbiting around it. But even among all of them, Io stands out as by far the most unstable and unpredictable. In fact, it's the single most volcanically active object in our entire solar system. It truly lives up to the wild energy of its name. The name Io comes from Greek mythology. She was a priestess who served Hera, the wife of Zeus. The god of thunder fell in love with her, and she returned that passion with a fierce intensity of her own. Even so, Io remained mostly overlooked by astronomers all the way up until 1979. It does have a diameter of 2,263 miles, which makes it a fairly large moon, slightly bigger than Earth's moon, which measures 2,159 miles across. But there are still moons out there that are even larger. The biggest one of all is Ganymede, with a diameter of 3,274 miles. Just to give you a sense of scale, that makes Ganymede about 8% bigger than the entire planet Mercury. But in March of 1979, Voyager 1 zipped past Io at a blistering speed of 38,000 miles per hour and snapped a series of photos that left scientists back on Earth absolutely speechless. What showed up in the images was a volcano caught right in the middle of an eruption. It wasn't dormant, and it wasn't just a leftover crater from an old eruption. It was active, erupting at that very moment. The exact instant Voyager flew past Io, magma was exploding out into space. This marked the first time in all of human history that we have ever confirmed a volcanic eruption on a world beyond Earth. That volcano was named Pele. Now, I'm sure many of you are picturing the legendary soccer player, but that's not where the name comes from. It was named after Pele, the Hawaiian goddess of fire. Then, just a few months later, in July of 1979, another messenger from Earth, Voyager 2, passed close by Io as well. And in the photos it captured, scientists counted not 1, not 2, but 9 active volcanoes, along with dozens of flowing rivers of lava and massive volcanic calderas. At this point, it was starting to feel less like science and more like nature was throwing down a challenge. But why would that be the case? Well, to understand that, we first need to ask, why do volcanoes form in the first place? What makes Io's volcanoes so unusual? On Earth, and really on most rocky planets and moons, the way volcanoes work is relatively straightforward and easy to explain. Deep inside these worlds, heat gradually builds up over time. That heat usually comes from just a few key sources: leftover energy from when the body first formed, the decay of radioactive elements, and the occasional meteorite impact. As this heat builds, pressure rises until eventually the crust cracks under the strain, and molten rock bursts through the surface in an eruption. On Earth, volcanoes tend to form along the edges where tectonic plates collide or pull apart, or in special spots like Hawaii, known as hotspots. Beneath the crust, there are large pockets of magma feeding these volcanic systems. All in all, it's a system that makes a lot of logical sense. But when you try to apply that same logic to Io, everything starts to fall apart. First of all, Io is just way too small. Its mass is only about 1/67th that of Earth. A body that tiny shouldn't be able to trap heat for very long at all. By all rights, it should have cooled down billions of years ago and ended up as a lifeless frozen rock like our moon. Second, Io doesn't have any tectonic plates. Its crust isn't shifting and grinding like Earth's does. So, of course, there are no subduction zones where plates dive beneath each other. And the third most shocking issue, there are just way too many volcanoes. So far, we've confirmed around 400 active ones. And if you count the ones that have already erupted or are temporarily dormant, or are too subtle to easily spot, the total might be over 1,000. That level of volcanic activity simply can't be explained by normal internal heat. In other words, the eruptions on Io aren't just random outbursts or occasional flukes. Erupting is how this moon lives. It's built into its very nature, which means the cause must lie somewhere completely different. So then, what in the world is powering all of this? How does Jupiter heat its moon? The answer didn't lie within Io itself, but just beside it. Towering above the moon like the ruler of gravity and true master of the skies stands the giant planet Jupiter. Jupiter has 318 times the mass of Earth and an astonishing 21,000 times the mass of Io. With that kind of size, of course, its gravitational pull is absolutely overwhelming. But Jupiter's gravity doesn't just keep its moons in orbit. It acts more like a cosmic torture device, twisting and squeezing with merciless force. We all know how the moon pulls on Earth's oceans and creates tides, right? Io orbits about 262,000 miles from Jupiter, which is only slightly farther than the 238,000 miles between Earth and the moon. But remember, Jupiter is 318 times more massive than Earth. So the tidal forces Io experiences are far, far stronger than anything we feel here. And here's where it gets even more interesting. If Io were orbiting in a perfect circle, all that would happen is a little tidal bulge on the side facing Jupiter. But Io doesn't follow a perfect circle. Its orbit is stretched into an ellipse. That means the gravitational pull it feels keeps pulsing and changing, squeezing and stretching Io's entire body in a constant brutal cycle. And that's where friction comes in. Inside Io, millions of tons of rock and molten material are grinding violently against each other. Just imagine how much heat all that friction must generate. It's the same effect as bending a wire back and forth over and over until it starts to burn your fingers. Of course, unlike a wire, Io's interior is made up of silicates, iron, and sulfur-rich rock. But those two heat up under intense stress. And that, right there, is the true source of Io's internal fire. It's not radiation and it's not residual heat from its formation. It's tidal energy. And we're not done yet. Io isn't just orbiting Jupiter all by itself. Two other moons, Europa and Ganymede, are also part of this gravitational dance. The three moons are locked in a special rhythm called orbital resonance. For every 4 times Io orbits Jupiter, Europa goes around twice and Ganymede once. Without this resonance, Jupiter's gravity would have smoothed out Io's orbit into a perfect circle long ago. But thanks to these neighboring moons constantly tugging at it, Io is never allowed to settle into a calm circular path. It's almost as if the gods themselves arranged it this way, giving Zeus's lover no way to escape her fate. The crushing grip of Jupiter's gravity, Io's elliptical orbit, and the endless nudges from its sibling moons all combine to turn Io into a kind of forge in space. There, under intense heat and pressure, lakes of lava boil, hundreds of volcanoes erupt, and massive explosions light up the surface, visible even from space. The intense energy surging through Io's surface. Between 1996 and 2001, the Galileo spacecraft conducted infrared observations of Io. What it found were areas with extremely high temperatures, along with strange periodic spikes in heat. Based on these results, scientists concluded that a massive reservoir of molten magma must be hidden just beneath Io's surface. Then, in 2011, researchers from Los Alamos National Laboratory and the SETI Institute released a new study based on Galileo's magnetic field measurements. They had discovered unusual distortions in Jupiter's magnetic field whenever the probe passed near Io, an effect that could only be explained by a vast layer of magma running beneath the Moon's entire crust. According to their calculations, a partially molten magma ocean stretches beneath Io's surface, just 19 to 31 miles down, wrapping around the entire Moon. And that's why Io is never, not even for a second, truly at rest. Somewhere on the surface, something is always exploding, cracking open, oozing lava, or bubbling with unbearable heat. As we mentioned earlier, there are over 400 active volcanoes on this small moon. The most famous of them is the mighty Pele volcano. Around its crater lies a bright orange ring of volcanic deposits, stretching more than 620 miles across. This volcano blasts out sulfur dioxide, fine sulfur particles, and noxious sulfur gas, sometimes shooting as high as 310 miles into space. Another monstrous volcano is Loki Patera. But this isn't just a crater. It's a massive lava lake, roughly the same size as the entire country of Israel. The lake's surface occasionally cools down and forms a solid crust. But then, all of a sudden, that crust collapses, triggering a surge of lava like a molten tidal wave. Picture it: the solid surface fractures, crumbles, melts, and sinks, and then a glowing mirror-like lake of fire reappears in its place. These fiery cycles repeat every 400 to 600 days. But volcanoes are just the beginning. Io has even more surprises beyond its explosive eruptions. Believe it or not, it has mountains, ones that by all logic shouldn't even exist. Take the Busal Montes, for example, one of the tallest mountain ranges in the entire solar system. These peaks rise nearly 11 miles high, towering twice as tall as Mount Everest. On Earth, a mountain that massive would collapse under its own weight. But Io plays by a completely different set of rules. Here, a strange and alien physics takes over. Technically, Io does have an atmosphere, but only in name. It's a wispy veil made of sulfur dioxide, with a pressure hundreds of millions of times lower than Earth's. In other words, it's practically a perfect vacuum. And yet, auroras have been observed dancing across Io's skies. How can that even be possible? The answer lies with Jupiter, because it's not just a gravitational giant, it's also a magnetic monster. Jupiter shoots out powerful streams of charged particles that rain down directly onto Io. These particles create auroral spots and arcs, and unlike Earth, where auroras appear at the poles, Io's glow mainly near the equator. Could life exist on Io? And now, to wrap things up, here's a question you might not have expected. Could there actually be life on Io? The answer is almost certainly not. For starters, there's no water. There's no carbon dioxide either. The temperature swings on Io are brutal. Most of the surface freezes at minus 260 degrees Fahrenheit, while volcanic craters can soar past 2,900 degrees. Even so, here on Earth, we've found living organisms that managed to survive near deep-sea volcanoes. So, could something similar possibly exist on Io? In theory, it's not entirely impossible. But realistically speaking, the chances are almost zero. One day, when we finally get there, we'll know for sure. And who knows, maybe Io will become the ultimate destination for extreme tourism in the future. In February 2024, NASA's Juno spacecraft flew just 930 miles above Io's surface. The dozens of images it captured revealed cracks, craters, lava plains, and even plumes of gas bursting into space. But despite all the interest, no missions have been planned with Io as the primary target. Right now, most of the scientific focus is on Europa, Ganymede, and Callisto, moons that have a much better shot at hosting life. If you enjoyed this video, be sure to give it a thumbs up and share it on your favorite social media platforms. Thanks so much for watching. We'll see you again next time. Take care.